All right, it is at the top of the hour here, so we'll go ahead and get started. So good afternoon, everyone. Let's try that again. Good afternoon, everyone. Good afternoon. Perfect. Yeah, we're going to make everyone like, what's going on in there? We got to go over there and watch that one. You already know what this means. It means this, right? This is what we're trying to do. And with the product that I'm about to show you and introduce you to, we're going to help you succeed at the products part. And what we're trying to do at Microsoft is produce some of the coolest products possible to make convincing the people easy. Because if the products are cool, they're all going to want to use it. And inadvertently, they're going to make doing DevOps easier because they're using the products that we need them to enable continuous integration, continuous delivery, infrastructure as code. So my job at Microsoft is to travel around the world talking about DevOps, getting feedback from our customers, and then taking that feedback back to the product team and saying, hey, we got to make sure it does this too. Because if it does that, more people will use it. That'll make the rest of this stuff really, really easy. How do we do this at Microsoft? We want you to do it continuously. We want you to do continuous integration. So for those who aren't developers, continuous integration is the process by which, upon every commit to a repository, the code should be downloaded, compiled, tested, and packaged for deployment. How many of you work in a team right now that does not have continuous integration? Okay, someone is lying in here, right? Because I've never once asked that question and no one raised their hand. Not one time. If you aren't, that's fantastic. If you are and you're ashamed to raise your hand, go back tomorrow and install it yourself, right? We give it to you for free. You do not have to get permission from anyone on your team because if you implement it, they don't have to know that you implemented it. If you're already committing to a Git repository and I add CI, they won't know that I added it until I'm the one still working when you break the build because I know better than to go get the latest because I know that you broke the build. Everyone else on the team is going to go get the latest version of the code and all their builds are going to be broken and they won't be able to work. So continuous integration, just go back and install it. Do not ask for permission to do so. And I think that's true about a lot of the things that we're going to talk about today. You don't need someone's permission to go do it when it doesn't cost you anything and it won't impede anyone else's progress. What you're doing is slowly adding value to your process. CI can do that, and CD can do that as well. Now, it's more than just packaging the software and deploying it. It's about learning from that code as it's running in production. The definition of DevOps, we harp on the word value a lot. You cannot just assume that you delivered value. You have to be able to prove that you delivered value. And the way that you do that is by measuring what's happening in production. If I were to just add a brand new feature, and we look at the telemetry and nobody is using that feature, did I deliver value? No. I just pushed random bits to a server that no one seemed to care about. But if I can actually prove that, yes, 95% of the people that visited our website after deploying that feature started using it, we know definitively that we delivered value. And that's really powerful when you're doing Agile. Because if you're doing Agile, you live by something called a backlog. It's a laundry list of any and everything that your product owner believes that your software should do. The goal of the product owner is to make sure that your product backlog is in priority order. So they're moving items around. All we're doing is assuming that they're right. How do we verify that the product backlog is actually in the proper order? This is the way that you do that. You monitor it while it's running in production. You just don't take someone's word for it. Because if you're coming from the waterfall world, I can promise you, your product owner thinks everything on that board is priority number one. They simply do not care what order you do it in because they're not going to ship it till you do them all. They completely don't understand what Agile is about. Agile is about shipping as soon as there is value. And a waterfall mindset is we don't ship it until all the features are done. So I really don't care what the priorities of any of this stuff is. We're just going to ship it when you get to the bottom. But actually monitoring the software as you produce it will actually help the product owner determine if it's prioritized right or not. Continuous integration leads to continuous delivery. Continuous delivery leads to continuous monitoring and learning. And that cycles right back to the start again. So this is a circle that you get on and you never get off. Once you kind of have the technology in place, there's a couple of things that you need as well. You need a platform that is flexible, that is powerful, and that is open. And we believe that that's Azure. It's definitely flexible. Right? There's SaaS, IaaS, PaaS, any type of services that you want, from VMs to serverless, we have that there for you. Powerful. Or a matter of fact, in Sweden, we're standing up a data center right now. We drop those things like crazy. I remember the first time I saw Scott talk about how many data centers we had. We already had more than Google and AWS combined, and I think we only had like 20 of them. Right? We have more than 50 of those things now popping up all over the world. So we have the power that you need. Basically, it's infinite scale. And it's completely open. We run 50% Linux workloads in Azure. A Microsoft company, Microsoft, runs 50% Linux workloads in Azure, which is just crazy when you think about it. I'm old enough, as I described in the keynote, I remember when Microsoft thought open source and Linux were the cancers of the world and they should be killed. And now here we are, the #1 contributor to open source on the planet, and run 50% Linux workloads in our cloud. Right? So we're not the Microsoft that you used to know. We're a brand new Microsoft that is flexible, that is powerful, and that is open to all the type of development that you're going to want to be able to do. The way that we enable that for you is the product teams that I was talking about earlier today. They produce 5 different services, and we're going to go over each one of these services here together. The first one we talk about is Azure Boards. We just also announced at Microsoft Build that Azure Boards is now in the GitHub Marketplace. So we don't care if you're using GitHub as your source control or our repositories as your source control. You can actually use Azure Boards to do all your planning. You can now upgrade those issues that you have in GitHub into actual work items that you can plan, track, and groom on your product backlog. We also have Azure Pipelines. I think is the crown jewel of this suite. It has been integrated with GitHub for a long time now. As Nat Friedman, CEO of GitHub, likes to say, Azure Pipelines offers the single most generous open source offering on planet Earth. If you have a public repository inside of GitHub, we will give you access to macOS, Windows, and Linux across 10 concurrent pipelines and unlimited build minutes for free. Right? There is no other CI system that even offers you all 3 of them. And they definitely don't give you that much build time for free, and they definitely don't give you 10 concurrent pipelines to boot. So if you have a public repository in GitHub, there is no reason you should not be using Azure Pipelines to do your build. Builds can be defined in YAML, they can be defined visually, the whole 9 yards. We also started announcing at Build that we now have a unified YAML, or what we're calling multi-stage YAML, to where you can not only define your CI, but you can also now define your CD in YAML as well. A single file that takes you from commit to production. Historically, you would have your CI be one file and potentially your CD be a separate file if you were lucky enough to find a system that had a YAML for release at all. And now you can actually do that with a single file using our multi-stage pipeline. Someone remind me to show you how to enable that. That's still in preview. It is not just going to be in your repo. You got to go to your avatar and say, show me these preview features, and then it will pop up. And someone please remind me to show you how to do that. That's Azure Pipelines. Then we have Azure Repos. We needed Azure Repos before we bought GitHub, right? We needed to make sure that people had a way to store their source code. Git has become the most popular source control system on the planet, so we made sure that we implemented Git inside of Azure DevOps. Before Git became popular, there was another form called centralized version control, or what we call TFVC, which we still support to this day. And there are times where Git's the right answer, and believe it or not, people, there's times when it's not. Right? Don't go to Git just because all your friends are going to Git. You go to Git when it solves a problem for you. And if you're doing a lot of game development with a lot of binaries and artwork, TFVC is a fantastic fantastic source control system because it handles binaries really, really well. We didn't have to add anything to it. Because to do binaries really well in Git, you got to add plugins to it. But for TFVC, you don't need to do that. And we're the only platform I know that offers you 2 different types of source control, centralized or distributed, your choice. Now the question is, well, now you do own GitHub. Where should I put my code? GitHub or Azure Pipeline or Azure Repos? Wherever you want. Because we do own them now. So there's essentially pick whichever one feels the best, and it integrates perfectly with all the rest of the tools on the screen. So the choice is yours. You can get with this or you can get with that. Doesn't matter to us. We get all the money anyway. Okay, so what's next is test plans. Test plans is for all the people who raise their hands. This is what I'm going to tell you about so you can tell all the testers about who clearly are not in this room. Right? You're here and you know they exist, and what this allows them to do is create their test configurations, their test plans, track their entire test matrices, and make sure that the manual test that they want to run against your code has a home inside of Azure DevOps, and allows them to track it against the builds that they get from Azure Pipelines. Everything on this screen here integrates with each other right out of the box. It's the traceability that used to be the crown jewel of our offering. From the time a person makes an idea to the commits into the repository, to the CI and CD and the test cases, they all naturally just link together. I can look at a bug failure in our test plan, tell you what build it was in, what work item they were working on, and what lines of code they changed that actually caused that bug to happen. Right? That's the beautiful thing here about using the entire suite. And one of the last things that we just added was Azure Artifacts. Has anyone ever heard of Artifactory, right, from JFrog? That's essentially their compete for that product. So to give you some idea what it is. This is competing with Artifactory. This is competing with like HP, Test something or other. I forgot what their product is called. This is competing with everybody. GitHub, GitLab, Bitbucket, Subversion, Mercurial, name one of them. That's what this is competing with. Pipeline, Circle CI, Travis, Jenkins, AppVeyor, all that kind of stuff. And this, the biggest competitor for this is JIRA. So if you're using JIRA already, you can replace it with boards. All those different things that you're using, chances are there's a tool here that'll actually replace that for you as well. Now you don't have to replace the tools that you already have. We went through a lot of effort to break these products apart. Back when we called it Team Foundation Server, we basically positioned it and marketed it as the one thing that you need. Rip everything else that you have out, replace it with TFS, and the world will be great. Well, it would have been great if you were .NET on Windows. If you were Java on Linux, we could get it to work for a lot of money, and it wasn't really good when we were done. But it worked, right? But it was painful. So what we did is we said, we got to fix that part. Our customers want parts of it, but not all of it. So let's go ahead and break all 5 services out and make them work really well for any language targeting any platform. But out of the box, they need to work really well together, which is exactly what they do. But if you already have a huge investment in Jenkins, you don't have to abandon it. You can actually have us pull the artifacts from Jenkins jobs and deploy them using release management. If you're already using Ansible, you can use it. You don't have to switch over to ARM or the Azure CLI. You can still use Ansible or Terraform or whatever infrastructure as code technology you want to use. And you can then interact with the stuff that we have. You can mix and match GitHub and Python and whatever other soup here. Another thing that's really cool is look at this down here. A lot of our customers have a multi-cloud initiative. We don't want to put all our eggs in one basket. We need to make sure that we can run on all the different clouds and even fail over from one cloud to another cloud should something bad happen. So obviously we work really well with Azure. The AWS team actually wrote an extension for Azure Pipelines that allows you to access every resource in AWS using our pipeline. That just goes to show you how good our pipeline is, that our competitors are writing extensions to make sure that you can use our tools to deploy to their cloud. GCP, they have a command line tool, and I'll show you that anything you can do from the command line, you can do from our system here as well. Right? So every cloud is accessible. Now, not only are the clouds accessible, also containers, mobile phones, IoT devices. There was a session today by one of my peers named Ed Thompson who actually deployed to a Commodore 64. Any language, any platform. I've seen our build agent running on a Raspberry Pi. Any language, any platform. I can deploy Java just as easy as I can .NET, just as easy as I can Node.js. It simply does not matter. The tools don't know what the languages are, nor do the tools care. They're going to version your software, they're going to build it for you, and they're going to deploy it for you. Any language you want, to any platform you want, including behind your firewall. Right? Everyone thinks that this stuff is for the cloud, but we have a lot of companies who, like Donovan, our infrastructure lives behind our firewall, and there's never going to be a time that we're going to stop that. How can I use a product that lives in the cloud, but deploy to my on-prem assets? That agent that I just talked about that runs anywhere can also run on your hardware behind your firewall in your organization. What you do is then register that agent with Azure DevOps out in the cloud, and it'll simply pull it, asking it if there's anything for it to do. As soon as there is, it'll say, great, I'm going to stay here behind the firewall, go grab code from this machine, copy it over there to this machine, run tests on it, and then I'll report the status back to you later. But nothing that I don't want to be on the internet will ever see the internet. Yet I get all the status and orchestration that I want. On-prem or in the cloud, we can actually deploy for you either way. Now, there's some people saying, even that's too much traffic hitting the cloud, Donovan. We don't want anything to leave our organization. At that point, you can actually install these products, Azure DevOps, behind your firewall, the entire infrastructure. It's called Azure DevOps Server. It's the same product that we have in the cloud. It's just updated slower. We update what you get in the cloud every 3 weeks, like I discussed this morning. And what we deploy to you on-prem, we update every 3 months. But now you have complete data sovereignty, complete control over your infrastructure, and if you don't want to be in the cloud, you're not forced to be at all. Again, you can use them individually, but I believe they are better together. This is just a suite of tools that allow your life to be a lot easier when you use them. So first question is, well, Donovan, how do I get started? I think this is going to work really well for us, but I need to know where to go and get started. You just go to your web browser, and you simply go to azure.microsoft.com, or you can go to dev.azure.com. There's lots of different URLs that'll get you there, and you're going to see a page like this. Everyone listening to the sound of my voice right now can get started on Azure DevOps for $0.00. You and the 4 people sitting next to you right now can go off and create an account, and all of you use it for free and create a startup and use everything I'm about to show you for free. Right? Now, when you add the 6th person, that's when we make all of our money back. Right? You're a successful startup now, you add that 6th person, and we're going to charge you a whopping $6 a month. Try to make back all the money we've been giving you for free. Right? This is a lost leader for us, to be perfectly honest. We do not try to make money on Azure DevOps. We're just trying to keep the lights on so that you deploy into Azure. Full transparency, for us, all roads lead to Azure, and we believe having the best industry tools in the world are going to get more people to use them and more people into Azure. So this stuff is essentially free for everyone. Okay? So you can go there. Another thing I told you to do is why don't you just go ahead and get inside of the GitHub. If you go to the GitHub Marketplace and just type in Azure in the search, you're going to see these 2 options here. One of them is for Azure Boards, and the other one is for Azure Pipelines. Azure Boards is always free. Doesn't matter if it's private or public repository. Doesn't matter how big it is or how much you use it. Azure Boards is always for free. Azure Pipelines, however, is not always for free. So let me show you how that works. So if I go ahead and click on this here, go down to set up a plan. At the bottom, you will see if it's private, you get all the stuff that I said, Mac OS, Windows, and Linux, 10 concurrent pipelines, and unlimited build minutes. If you want additional parallel jobs or you want private repositories, we will start to charge you for those build minutes. You can also set up your own build agent, which kind of gets around some of this stuff because we don't charge you for the private build agents, at least not the first one. Okay? So I just wanted to show you really easy, getting started, very simple. And once you start creating one, if you're already using, Office 365, the account that you're using there is the same account you're going to use with your Azure DevOps. We're just simply backed by AAD, which means your organization who has already adopted OS 365 is already ready to start adopting this. There's no mapping of your users and no worrying about having 2 different logins. You basically log into one, you're automatically going to be logged into both of them. And we're working really hard to make sure that when you log into GitHub, you will automatically be logged into what you have inside of Microsoft as well. So that's coming as well. So again, getting started, very easy. dev.azure.com, or go to GitHub and search the marketplace, click on any of those links, and you can get started for $0.00. I just cannot stress that enough. How many of you are .NET developers who have an MSDN account? So everyone who just raised their hand, you do not count against the 5 that you get for free. So the 4 of you over here can start a startup and still add 5 more people for free and have a team of 9 and don't pay a dime for it. If any of the people that you add also have an MSDN, they don't count either. Right? Because with your MSDN, you've already paid for all this stuff. When you're in an organization that does both Java and .NET, all your .NET people are already paid for. It's usually the Java people that we have to go ahead and start paying the $6 a month for them to start using the product. All right, Azure Boards. This is our JIRA compete. This is the product that you will use if you want to do all your agile planning, Kanban boards, dashboards, the entire 9. What I like about Azure Boards is that it actually drives by what we call a process template. A process template are rules that understand how you write software. For example, if you're a Scrum shop, you would say words like product backlog item, impediment, and you run in sprints. But if you're a pure Agile shop, you say user story, you run in iterations, and you have issues. If you're a waterfall shop, you have requirements, change requests, and the like. Our tool understands that. You can choose between those 3 processes, and then we will change the vocabulary and the menus in the product to match the words that you should be using in your daily stand-up. Too often, you use a generic type of tool that doesn't understand how you write software, and it doesn't map really well to the vocabulary that you use on the daily basis, and then you're trying to say, okay, I said user story, but what does that map to in the tool because the tool doesn't use that word? We fix all that stuff for you. The words you use every day are the words you're going to see in the product. Another thing that's really nice about the product is that you can actually customize it. So if you're kind of scrum or fall or you've kind of tightened up the rules of whatever you're doing in your process, you can actually come in and customize it. I'd highly encourage you don't do that. The reason why is because the processes are the way that they are because they're really mature and they've been that way for a long time. And don't just go in there changing it because you can. Make sure that the change that you're making is necessary and you're not just bending the rules of the process yourself. That being said, we do allow you to customize them. I'll give you an example of where I customized it myself. So I always give that warning, but I want people to really think about the customization. OKRs are becoming really, really popular lately. That's objectives and key results. It's a planning technique. And the thing is that none of our templates, the 3 that I just mentioned, have any understanding of what an objective or a key result is. So what I did is I like the Agile template quite a lot in our tool. I derived from the Agile template and added the concept of an objective and a key result as work item types inside that process. So now when you go to the menu, you can actually create an objective. And you can link it to a key result, which is exactly what I need to do to track my OKRs. What's also really fun about the extensibility here is we have webhooks that fire at all different times throughout the life cycle of builds and product backlog items and all your work items. And if you're new to OKRs, one of the things that you're supposed to do is at the end of your quarter, you're supposed to grade your key result. The average grade of all your key results, which is going to be between 0 and 1, will be the grade of the objective to which they're linked. I didn't want my engineers having to worry about doing all the math and making sure that they remembered to update the objective. Thanks to the webhooks inside of Azure Boards, I was able to use an Azure function, and you get 1 million executions of an Azure function a month for free. So essentially, my team is not that busy. So I get this basically for free, and I wrote a Azure function that gets notified every single time a key result is updated, uses that information to then go find the associated objective, averages the scores of all the linked key results, and then updates automatically the objective for my team members. So all they focus on is grading their key result, and the back-end system takes care of all the rest. Just imagine the flexibility that we've given you by making sure that all these events are fired in a way that you can actually behave and respond to them inside of Azure Functions, Docker containers, anything that can basically take a webhook, you can now use to extend the functionality inside of Azure Boards and inside of pipelines, the whole 9 yards. So let's go look at how we use this. Now, I don't mind people taking pictures of a lot of stuff. Do me a favor and don't take as many pictures of what I'm about to show you. Reason why is because I'm going to take you inside of the actual dashboard of one of the teams on the Azure Pipelines, on the Azure Boards team. And I don't want you leaking some of the features that are about to come out. So this is special for you to be able to see how we work, but don't get me in trouble, right? And then there are people like, hey, I didn't know that feature's coming. Donovan just showed it at NDC. No, I didn't. I was just trying to be nice. So this is a dashboard. One of the cool things about our dashboards is that they can be completely customized. The data on this dashboard does not only come from inside of Azure Boards or inside of Azure DevOps. I have one of my dashboards where we have application insights. For those who don't know, application insights is a monitoring technology. You can put it inside your application, and then you send the telemetry to Azure, and then you can aggregate that telemetry later. It'll tell you things about how many server errors you have, what your response time is, things like that. Well, I don't want to have to go to the Azure portal to look at that data. I want to come here. Here I have how many times I commit code, how many builds I'm running, and the last release. And thanks to the widgets, I was able to bring in the information from Application Insights and put it on the exact same dashboard. So I have this beautiful heads-up display that says this was the last release, and this is how healthy that release is right now running in production from data that we're getting inside of Application Insights. I can see who my teams are. I can see what sprint we're currently in. As a matter of fact, we're at the end of a sprint right now. I can see how many active bugs we have. Well, this is good. Last time I showed this, these numbers were a lot worse than this. So this is progress, which is good. If you scroll down here, some of them will start to load asynchronously. You can see what pull requests you're participating in. You can see what the velocity of this particular team is. And you can actually write your own widgets. You're going to hear me talk about extensibility a lot because I think it's a really powerful feature of the tool set. I don't even know if I would call it a tool set. This is more like a platform. Webhooks on the way out, that widget are all written by us, and you can actually write your own as well. We have lots of people in our marketplace, and let me show you where that marketplace is real quick. So if we're to come over here and go to our marketplace is where we have all these types of extensions, and many of the extensions in the marketplace add additional widgets to Azure DevOps so that you can actually start showing some really cool stuff. Here, for example, are some of the top featured products. Many of these actually have dashboard widgets that you can then add to your dashboards to make it a much more rich experience for all your developers who are using the product. These are extremely easy to write. If you know HTML and JavaScript, you can write one of these. And the way that you learn how to do that is you simply go to docs.com. And from docs.com, you click on Azure DevOps. And down here in the right-hand corner, You simply go to Discover Extensions, Develop Extensions, Integrate the application. So this gives you samples of ways that you can go back in and extend Azure DevOps to do things it doesn't do out of the box. And trust me, it's really, really easy to do. I've actually written several custom tasks, and I'm proud of 2 of them because they ended up in the box. And what I mean by that is that we take pull requests on our Git repository because all of our tasks are developed in the open in GitHub. I had the Docker task was originally written by me. The SSDT task was originally written by me. I wasn't willing to wait for the team. I had a demo I had to go do. I wrote them. My boss saw them. Next thing I know, they're in the box, right? So it's really an open platform. And all I did is I took some of the ones that were already there, modified them, made them a little bit better, and next thing you know, they're being shipped, which is really, really cool. Another thing that I love to play with is the REST API. I wrote a PowerShell module just for fun. And next thing I know, it was downloaded 316,000 times. So it's a big deal and has 26 contributors. And all we're doing is basically wrapping all the parts of the REST API that we need to do whatever it is that we're trying to do. And now you can just download VS Team, start playing with it. And if you are interested in it, I'll give you one more tidbit here. So we'll just go to the PowerShell gallery. Just come here and search for VS Team. And this is the one that you want. So yeah, it's up to 318,000 downloads. It's an open source project, so you can actually use this also to learn how do I call that REST API? How do I make Azure DevOps do a lot of cool stuff? There's a whole library of code there that you can now leverage to figure out how I actually do this and extend it even further. So another thing I want to show you here. So if you come back here, we can come here and say, hey, let's show me the Kanban board. The Kanban board is just what you'd expect, but it's extremely extensible as well. You can customize it and color code some of the board tiles here. You can control what your whip limit looks like. You'll notice that some of these are actually a different color. The reason that there is different colors is because we have rules in the back end. And the rules are looking at some attribute of that particular work item and says, oh, when this is true, you're supposed to be a different color. What's really nice about that is if something is blocked or something is priority 1, you can actually have its picture or color automatically change to make sure that it doesn't get lost. Because the more you use this, the harder it gets to see all the cards. It's just the cost of doing business. And what we can also do here is if I scroll back down, I can collapse this one right here. And you can see there's other lanes below it, right? Customer delighters, which are lower priority than a DRI. DRI, this is things that we're doing for live site incidences. If we have an emergency inside of Azure DevOps, that's clearly the most important thing that we should be working on to make sure that the service is still reliable, which is why it's the top lane inside of our Kanban board here. But as you can see, you can customize it. You can add additional ones if you want to, and you get a nice summary when you go ahead and start to collapse this. These numbers here are called WIP. They're called WIP, stands for work in progress. The top number is never supposed to be bigger than the bottom number. So we'll go talk to the team about that later. But it's nice for you to have an indication of just how much work you're actually trying to take on. The whole goal of that is so it makes you get more work done by forcing you to finish something before you take something out. My next feature request is going to be if that number is already the same and you try to drag something in there, it just bounces it back out until you get some stuff out of there. Because right now we just keep letting you add to it and we just change the number, but I think we need to be a little bit more aggressive and deterministic about how we're going to do that. I can also go back over here and look at our feature timeline and our epic roadmap if I needed to. So these are ways that I can re-visualize some of that information. Another thing that I want to show you is what our product backlog looks like as well. I'm having a little trouble with my internet. There we go. So here I'm actually able to start to visualize what releases, because we basically run in sprints here. Let me zoom in a little bit. And we can see exactly what releases along the top, these sprints here that we're using, and when I'm actually going to see certain things actually drop and get released out into the environment, and what sprint we're currently on, and things like that. Another thing that I want to show you here, let me expand this so you can see some of the variety of stuff we have here, is if I go to our backlogs. Now our backlog is just that laundry list I talked about before that has everything in priority order for you. I like having this particular screen up during my sprint reviews. So if you're an Agile or a Scrum team, you should have a sprint review at the end of every single sprint. That's where you show your stakeholders all the cool software that you developed in the previous sprint. It's a fantastic place for you to go query feedback from your users to add to your product backlog. So as the Scrum Master, I'm sitting in the back of the room. I have this screen up, and every time someone blurts out a really cool idea, I just quickly jot it in there, and then later I sit with my product owner, and we adjust the priorities of all the cool new ideas that I just heard. So it's a great way for you to be able to use the tool that you're going to be planning in to go ahead and capture that information as well. If you needed to, you can go ahead and expand some of these items here. As you can see, there's hierarchies where you can actually build a hierarchy from your epics to your features to user stories, all the way down the line. And then when you click on one of these things here, you'll be able to see the anatomy of a particular work item. I like this a lot better than issues because an issue is just a blank text box. You don't know if it's a bug or if it's a feature or if it's an enhancement. You don't know what it is until you sit there and read everything about it. But what we do here is we actually create different types of objects. This is clearly a task, and the anatomy of a task is different. There's things I want to know and things I'm going to ask about a task that I'm not going to ask about a bug. And I like the fact that I'm able to identify what it is and give it a particular anatomy about it as well. Obviously, you can plan out your sprints. You can run queries against all your work items. You can mass edit these work items inside of Excel if you want to. I remember I felt really bad for this person. So one of my people are going on vacation. So I go into Excel and I run a query that brings in all of their tasks. Then what I did is I changed the first name to Richard, and I just drug his name down on everything else, right? Using the power of Excel to make batch edits. And then when I pushed on publish, he just started crying because now he had like 35 new tasks against him. I giggled a little bit because I thought it was awesome. But it's like how quickly I was able to ruin this person's life while my buddy went off on vacation. So if you need to make mass edits, you don't have to use the web interface to do it. You can actually bring it into Excel or Microsoft Project. I kind of frown on Microsoft Project because they bring them in there and they create Gantt charts. And Gantt charts are a relic of waterfall. And if you're doing that, you're probably not wanting to use the tool the way that we want you to be using it. But it does integrate with Project too if you have people insisting on you actually using Project instead, which hopefully you don't have right now. So again, we have the work items themselves. Those are the actual entities that you can actually create. And as you notice here, if I pull down this drop down, there's several different types. This list is longer because we've gone in and we've customized it to have additional work item types than you would normally get out of the box. Out of the box, again, it's much smaller than that, but we run a service that runs 24/7, and live site is something that's really important for us, so we had to customize our process template to fit the way that we do business here inside of Microsoft. Again, highly customizable, allows you to do your planning, Kanban boards, task boards, backlogs, everything that you need to do to be able to plan and track your work. Azure Boards, again, integrates really well inside of GitHub. You can actually use AB hashtag and the ID of that particular item in Azure Boards to link it to your issues inside of GitHub. And there will literally be a link created inside of GitHub where when you click it, it takes you back to Azure Boards. And in Azure Boards, you click it, it takes you back over to GitHub. So you get that two-way traceability. It also integrates with your pull requests inside of GitHub and also with all your commits. So if in your commit comment, you put AB hashtag and the ID of a work item inside of Azure Boards, it will automatically show up as a link in your commit history, also in your pull requests, and also with your issues as well. So it's a really nice, tight integration between Boards and with GitHub. Now let's talk about Azure Repos. Again, Azure Repos predated our acquisition of GitHub, so it was clearly a necessity for us. Right now, you can actually choose wherever you want to put your code. If you prefer putting it in GitHub, that's great. If you're doing open source development, you should be putting it in GitHub, right? Even though we support private projects inside of Azure Repos, it's really not the best place for you to go get that community contribution, the type of collaboration that you get, the forking capabilities for open source. I honestly believe it's better to be inside of GitHub. Now, when you're talking about code that you're never ever going to open source, code that you want to make sure is private, to me that's a different discussion. Because we give you unlimited private repos here for free. If you're already using it, you don't need to get off of it. Whatever Git repository you've already chosen, chances are we can already integrate with it. We have great integrations with Bitbucket. We have great integrations with GitLab, GitHub, GHE, our own, and even any generic Git repositories. If you can give us a URL, username, and password, we can go and get your repos for you any way that you like. So what I'm going to do is this is one where I'll let you take pictures of some of the pipelines, but again, I'm about to show you the actual repository or where this code that builds Azure DevOps lives. So please, if you don't mind, keep the pictures and cameras away for a little bit. So what we're going to do now is we're just going to hop over. This is the actual repository where we're actually building Azure DevOps every day. We do trunk-based development, which means all 50 of our feature teams merge into master every single day. This tool was the first tool that could ever handle a mega Git repository. What I mean by that is the Windows Git repository tops around 350 gigabytes. It is the largest Git repository on record, and Git was unusably slow when we first tried to use it with Windows. A Git status command should take what? A couple milliseconds at most? Should come back instantly? 5 minutes to do a git status on the repository to find out that you didn't change anything. Like, can you imagine what of a waste of time that is, right, to go try to do this? To clone the repository was just shy of 3 hours. It was unusably slow. So what did we do? We invented something called the Git Virtual File System. So if you search for Git Virtual File System, we invented that simply so that the Windows team could actually use Git like the rest of the human beings on Earth actually use Git. Then what we did, being a good open source citizen, is we open sourced all the code for GFS, and we actually put it back in there so our competitors at the time, GitHub, GitLab, Bitbucket, can go all implement this so that you can start utilizing really large repositories. But this, out of the box, ready to rock and roll. Windows is the biggest now, but Office is also on the migration to Git, and we're estimating that their repository is going to top 450 gigabytes. And without GVFS, there would be no way in the world the Office team could actually use Git on a daily basis. So this stuff scales like mad. Another thing that's really nice is that you can see it's a great visualization, very fast experience. You see all these branches coming back in because we use short-lived feature branches on our team. And what we do is every feature branch has to get merged through a pull request. I'll show you a little bit of our pull request experience here as well. And what's really cool about our pull requests are the policies that you can apply to them. If you scroll back up here, you can see these are actually already running some builds here. So this is a pipeline that's currently in status of someone trying to merge their code back in. And here's the pull request hash that we just had. Our build system is really smart to be able to determine, based on where the code is coming on from, what build definition it needs to run. So some of these are running pull requests, some of these are running CI, all based on where the code's coming. So here what you're looking at is our experience for a pull request. On the right-hand side are all the policies that we currently have applied. For example, people have to run a cred scan. People have to run a build. So you can't check in code and try to merge it into master that does not actually build. And if we go ahead and click on that particular link, it'll take us to the build definition itself. We have a really rich ability for you to see all the files, the comments. You can have a conversation with your developers. Just for fun, we can do emojis and animated GIFs and all that kind of stuff can be put in here to kind of ease the burden of being torn down during a pull request. You can have some fun with it if you want to. So I actually really do like our pull request experience here. I think it's a fantastic experience. You can obviously do the normal stuff, look at the files that were actually changed, compare the commits that were actually used, verify if there was any conflicts in there at all. So going back over to the overview, if I were to click on build succeeded, and this build has to succeed for a period of time. If this pull request sits there, I think it's for 9 hours, without getting merged back in, we assume that the code has migrated and that build has to be rerun again to make sure that your code changes haven't diverged too far from what's currently in the master build. So it's not just, oh, I passed a build a week ago, let's go merge my code. It's like, no, we need to make sure that your code is still good. So if that build is too old, we won't actually let you in. You can also see here as well that we had approvers that had to come in, and we can designate these approvers by the folder that the code is in, what team that they're on, if there's groups or individuals, to make sure that the right eyes are actually looking at this before it gets merged back into our master branch. So let's just go ahead and take a quick peek at this. This is just a little teaser of what we're able to do with some of our stuff here. This is a PR pool, and I think the PR is only running about it's only running about 27,000 tests. And I say only because at our high point, we have some builds that are running 89,000 tests against your code before it's allowed to get merged back into master. If a single test fails, it stops. You get an email saying, guess what? You got to go find that needle in a haystack and find out why that one test failed and try your pull request again. But even on the fast pull request, you're still having to survive nearly 30,000 unit tests before your code will actually make it inside of the master branch. But I don't want to get ahead of myself there. So obviously we have our repos come along with our commits, our pushes, branch information here, pull requests. And this one right here you're not going to see, this metrics and analytics. This is another example of an extension that we've added that gives us a little bit more insight into the metrics and the analysis of the way that our branches actually come together, because we do so many of these. When you have 700 engineers merging into master, you average about 600 pull requests a day. That's a lot of data to churn through, so we actually had to write some additional stuff. Another thing before you ask me, Donovan, what's this thing down here called compliance and engineering in one branch? All that stuff is extensions. You will not see that on your account, and there's no way to turn that onto your account. The compliance is coming, right? So you will get compliance eventually. The other stuff right now is still in development. Speaking of how do you turn on stuff, so that I don't forget to tell you, if you come over here, and I actually want to go to a different account here. Let me go to this account that I have full admin rights over. go to preview features here, and this is where you can toggle some of the features that you might see in a demo by a Microsoft person that you don't want to like, hey, why don't I see that option on my Azure DevOps? Reason why is probably hasn't come in here and turned it on. The ability to define your build and your release as a single YAML file, that's this one right here that I have turned off. The reason that I have it turned off is because the account that it's on right now has a very specific demo that I use using the graphical user interface as the build definition. Right, that demos really well, it's very clear, and by turning this on, it changes the whole behavior, so I have it turned off. And that's what you can do as well. You can turn it on for different accounts, different projects, even different individuals. Because if you scroll up to the top, I can say only I want to see this, or I want to apply this for the entire account all up. It's completely up to you. So what I would do is every 3 weeks, I would just come and take a quick peek in here, because every 3 weeks is when you're going to see something else pop in here. We use this information here very strategically, because if you turn something on, and then a day or two later turn it back off, that's telemetry for us. You clearly did not like the experience that you had, and sometimes we'll ask you, why are you turning that off? Remember in the keynote I talked about listening to our customers. This is another example of where we're trying to figure out, oh, you turned it on, but now you're turning it off. What did we do wrong? Give us some feedback so that we can try to make it better. Because what we're looking for is that 90% of the people that turn on a feature leave it on. That gives us a good indication that we're on the right track, and then we make it an actual feature and not something that you have to turn on afterwards. So here what we're talking about here is, again, just talking about repositories. If you're already using a Git repository, I wouldn't necessarily switch who you're currently using. If you're not using it or you're transitioning from VSS or some other source control system, I'd give repos a really hard look if you're not doing open source. Right? That's the way that I help customers decide on where their source code should actually be. And as you can see, if it works for Windows, it's definitely going to scale for some of the things that you're going to need to do with it as well. Now, actually, I think I clicked too far. Yeah, we were just doing repos. Now we're going to talk about the crown jewel, my favorite one. This is Azure Pipelines. This is where you're going to do all your CI and CD. And one of the demos that I'll do, and I'll actually show you the pipeline. I have a pipeline that's so sophisticated that when I go on stage, I delete every resource in my Azure subscription before I do this demo. That means infrastructure as code is fired up, everything. And when I try to go to the resources, like the websites, there's one called peopletracker.us that I use. I type in peopletracker.us, clearly it doesn't load, because I deleted the website right out of my freaking Azure subscription. I go to a mobile application that used a web service in the back end as its data store. Gone. App starts closing. All I do to get everything back is push a button. I simply queue a build, and I relax. It deploys all of my infrastructure. It even stands up a new Kubernetes cluster, who you got to remember whose IP address is going to be different than the IP address that's registered in GoDaddy as my DNS record. So what I do inside of my pipeline is I query the new IP address, use the REST API at GoDaddy, and I update it as part of my freaking pipeline. So there is no human intervention to recover from a disaster. You can literally delete everything I own, and I can push a button and get everything back up and running again. That is the holy grail of DevOps. That a disaster recovery is just a deployment. This is just how we deploy our code. All the infrastructure's in there and everything, and I'll show you what that pipeline looks like. Again, highly extensible. You can go in there and write your own tasks. For example, what I did is I actually wrote a PowerShell module for GoDaddy and was able to pull that PowerShell module down as part of my build process and then utilize it on Mac, Windows, and Linux machines hosted for me in the cloud. Another thing that I like to do is that it's completely open source. So our agent and our task library is currently in GitHub, and you can go see exactly how we wrote it. Our agent is completely cross-platform. As I said before, we've had it running on a Raspberry Pi, Mac, Windows, and Linux, on-prem or in the cloud, our cloud or somebody else's. So it's extremely flexible. Anything that you can do from a command line and anything that you can do from a REST API is now full game for you as part of your pipeline. I haven't met a problem yet that I haven't been able to solve. Someone asked me, Donovan, can I do all this stuff with VB6? I'm like, yes, all this stuff will work with VB6. He asked me to prove it. It's like, fine, whatever, let me go prove this for you. So I did. You know what the hardest part is? Installing VB6. It won't install on a modern OS without crashing multiple times. So I wrote an entire blog post. 75% of the blog post, how to install VB6 in 2019. Once I got it installed, the rest of the stuff just worked because I was just calling command lines at that point, right? So I want people to free their minds and realize that this platform is amazingly extensible. It goes beyond just CI and also goes to CD because the engine, the platform, the underpinnings is exactly the same. So everything I just said is true about CI is also true about our CD system. What our CD system does for you is it adds different concepts. Concepts of environments, concepts of approvers, concepts of release gates, things that you don't have necessarily in CI, we've now added into our release pipeline, but it's the exact same engine, exact same rules. So let me show you how this stuff looks. So let me see how much time I have, because I can get lost in our pipelines. I like them so much. So this one right here is a really cool pipeline, because historically, when I had parts of my code that had to be built on Linux, parts of my code that had to be built on Mac, and parts of my code that had to be built on Windows, I had to create 3 different build pipelines, sometimes using multiple tools. Because if you go inside GitHub right now and look inside of a public repository, chances are you're going to find more than one YAML file. You're going to find an AppVar YAML file and a Travis YAML file, or a Circle CI YAML file and another YAML file, because they're trying to get to all the different platforms. Microsoft is the only person where you can have a single YAML file and still get to Mac OS, Windows, and Linux. And what I'm doing right here in this single build is doing just that. So instead of multiple builds, here at the top, I have a portion of my build that's doing a .NET Core application, and I happen to be building it on Windows. Then I scroll down because this solution actually has a Docker container in it, and I build that Docker container on a Linux machine. And then what I do is I upload all that code to a Docker registry, which I'll be using as part of my pipeline. After that, I come down here and I'm doing another set of Windows development. Here I'm doing my Selenium test, so I can do integration tests during my pipeline. I'm creating an SSDT package, which is SQL Server Data Tools, so I can actually upgrade my database schema as part of my pipeline automatically. And I also have a full framework.NET web service that's going to be deployed inside of App Service, all being built on a Windows machine. I didn't stop there. Then I wrote a Xamarin front end that allows me to run this application on iOS and on Android, and that part has to be built on a Mac. Now, I did not have 4 different builds. I have a single build running across multiple languages and multiple platforms all at the exact same time. And when I say the exact same time, I mean when I commit to this repository, all 4 of those build jobs start at the exact same time. It's not one after the other. They're all running in parallel, and then at the end, they collect all of the output and hand it over to our release system. So what I can do here is let me take you to the summary of what this looks like. And I also did some other cool stuff in here, like security scanning as well. So if I go to the summary of this particular builds, what I'm going to be able to see here, let's just go ahead and click on this one, is now I get to see the status of every one of those different phases, what operating systems they were running on. From the summary, I can see what artifacts were actually produced. I can even see where it went through my pipeline, which I'll show you here in just a second. Down below, I can see what code coverage I have. It's not too shabby, 54% code coverage. I can see that all my tests actually passed. 31 of my tests, all succeeding, none of them are flaky. And I even went back in and I did a white source bolt scan to see if any of the packages of which I depend upon actually have vulnerabilities in them or not. I don't want to be the next Equifax. I don't want to take an open source package from NPM or NuGet, add it to my project, and then be vulnerable. So what I had this tool do is actually sit inside of my build for me, analyze all my packages, and then generate a report for me, letting me know if there's something bad in my pipeline or not. My pipeline is protecting us not only by running tests, but also by running security scans to make sure that our code is actually healthy. Once all this stuff is actually done, if I go back to my summary, we can actually click on this particular release here. And it takes me over now to our release pipeline. This is the pipeline that took all the things that I just built and actually deployed it out for me. This first 2 here are doing infrastructure as code. Those 2 are the reason that I can delete everything inside of my Azure subscription and make sure that it all comes back again. There's certain stuff that needs to be common for dev, QA, and prod that I put in a completely separate resource group. Then I go off and I provision the infrastructure for my dev environment, at which point I start to deploy some of my services here. Let me zoom out just a little bit. So you can see that I'm actually deploying my web service, I'm deploying my database, and I'm even deploying inside of a Kubernetes cluster using Helm that I just spun up with a task before. This takes your entire infrastructure and provisions it for you. When all that is done, I come back up here and I start making sure that my mobile app is successfully deployed to all my beta and alpha testers. I'm then also able to take the Xamarin Test Cloud, take my IPA and my APK files, upload them to physical devices in Denmark, and run actual automated UI tests against physical devices as part of my deployment for integration testing. I then also run Selenium tests against the website to verify that my front end, my backend, my database, my Docker container, and my mobile apps are all working the way that I expect them to. And in this process, I also reach out to GoDaddy and say, oh, by the way, here's the new IP address for the DNS record that you have to make sure that all of our customers have a seamless experience as we recover from a disaster or as we go ahead and update our new features for our process. And then all I have to do is rinse and repeat that for QA, and then rinse and repeat that one more time again for production. I can have approvers come in to this particular process for me. For example, let me go ahead and edit this pipeline for you so you can see what this looks like. So if I come in and I edit this particular pipeline, I can click on these icons here and have access to all kinds of cool stuff. For example, I can have pre and post approvers. Let me scroll down here. By enabling this feature here, I now can put users or individuals or groups inside of here and say, Donovan has to come in at this point of our deployment and say it's okay for us to continue or not. So imagine that you have a QA environment. You want your manual testers to go inside that environment and verify that the code works before it goes into your staging or your production environments. You could actually put them not at the beginning of the environment, but you can actually put them also at the end of the environment. So now that it's been deployed into QA, you want to make sure that they come in here and verify it. And if and only if your QA lead says it's okay, will the code actually continue its way into the next environment in an automated fashion. You have complete control over the movement of your code. Now you're thinking out loud, but Donovan, we use ServiceNow. We need not only human beings to actually interact with our approval process, we need the ability to have automated systems interact with it as well. And if you come down here to our release gates, you can actually see you can add things like ServiceNow to your pipeline. So if you're using ServiceNow in your organization, or a matter of fact, any third-party system that you have to go through to get approvals done before you can move your code, we'll actually have our tool talk to that tool for you. So gone are the days where you have to manually go do stuff, send emails to each other to get someone in here to go click the button. You just tell us, hey, Donovan, the item's in ServiceNow. When that thing goes green, come back over here and start this process back up for us again. We are trying to automate every possible phase of your deployment that we can. Inside of these tasks, it's pretty simple. You come in, let's do something that's a little bit more fun with a little bit more task. Here we go. So I'm going to go ahead and click on this here, and you can see exactly what I'm doing. I'm using Azure CLI to do a little bit of resource renaming here. I'm going off and installing Helm. I'm running a deployment, and then I'm using the GoDaddy package I talked about to go update my DNS record based on the IP address that I just got from my Kubernetes cluster. If I need more tasks here, I simply go to our task library. As you can see how small this little thumb over here is, we have hundreds and hundreds and hundreds of tasks right out of the box. All these tasks are written in open source, which means you can go see how we wrote them and then go back in and write your own. Now, I doubt very seriously you need to write any of your own, because if you come over to the utility tab, you'll realize that we can run any bash script that you already have written, any batch script for the command line people from the old days that you've already written, run any arbitrary command on any platform that you want, and we can also go back down here and we can run PowerShell on Azure machines or directly on the machines that you have as well. So anywhere that you want to run any of your command lines, you can actually do it. So I'm a big fan of PowerShell, and we actually have two different ways of running PowerShell. You can run PowerShell in Azure, having all the Azure stuff already authenticated for you, or you can just run it on an arbitrary machine. Oh no, by the way, PowerShell runs on Mac, Windows, and Linux. Right? A lot of people don't realize that we've not only open sourced it, we also made PowerShell cross-platform so that you can use the exact same language everywhere. And that task that says PowerShell is smart enough to determine what platform it's running on and make sure .NET Core is on there and actually execute your exact same PowerShell the same way no matter where the code actually is living. All right, so another pipeline that I want to show you here is this one here. So people always ask me, so Donovan, this all sounds great, but how crazy can I get? How big of a pipeline can I actually build? This pipeline that I'm about to zoom out for, and when I zoom out, you can take pictures of this stuff, by the way. This is actually a public project that you can see anyway. What YoTeam is, which is the name of this project, it's a command line utility that basically stamps out pipelines for you. And it works on Node.js, Java, .NET Core, and full framework.NET. It also works on PowerShell. And it also works on, so that's the languages that it does. Then you have to look at the targets that it has. App service with deployment slots, app service running a Docker container, ACI, Kubernetes, and your own private Docker host. When you do the math of all those languages against all those platforms, you end up with a pipeline that looks a little bit like this. So we have 5 parallel lines, and all these are doing is actually running integration tests. And if you scroll all the way over, eventually, 3 hours later, your code will be completely tested, and the last thing I do is I automatically publish it to the NPM gallery for me. When I tried to do this by hand, I never got through all the testing. I'd eventually get frustrated and give up, and I would just push code to the NPM gallery, just hoping that it actually worked. Now that I've actually done this, I'm actually able to take every pull request that I get from the public, run it through this machine, and if it gets to the end, I know that code is bulletproof. I think I saw a hand go up.
Yeah. I was wondering if you're having artifacts which include PDB files, how would you handle that? So in certain environments, you want PDB files to be present and others not.
All right, so the question is, if I have PDB or basically debugging symbols that I also want to deploy for particular reasons, how can I handle that? In the build system, you remember I had those artifacts that I was publishing? I could actually publish both the release version and the debug version as two separate packages for the exact same build. What I would do then is in each of these environments, depending on which one that I wanted to, I could pull down either artifact that I needed to with or without symbols. So you have the flexibility of doing both of those. That's a really good question. But what I wanted to show you here very quickly is just the potential that we have when it comes to building really gnarly and complicated pipelines. This thing will scale to whatever level that you need. Okay, I only have like 5 minutes left. So again, I could talk your ear off about pipelines. We give you access again to Mac. Here's one more thing I want to show you here that people just don't quite understand until I show them. Let me zoom back in, and I'm going to show you our agents that we give you access to. So I'm going to come in here, and I'm going to show you what our agents look like. So here, as you can see, are all the different agents that we have. Everything that starts with the word hosted is just sitting in the cloud waiting for you. And you'll notice that there's Macs hosted in the cloud waiting for you. There's Linux machines waiting for you, and a whole slew of Windows machines and Linux machines. Now, everything down at the bottom that says private, those are agents that I stood up myself, and I registered them with the system, and I can then target them from this system no matter where they're deployed in the world. So this is what gives me access to Commodore 64s and Raspberry Pis and machines behind my firewall. But you don't even have to install anything to get to all three platforms if you need them, which is really, really nice as well. All right, 4 minutes left. So I'm probably not going to show you test plans too deeply, but test plans allows you to basically do all of your manual testing. Set up your test configurations, set up your test matrices, test both web and Windows clients if you need to, and it allows you to track everything inside of the tool set. The test cases that you create and the test plans can actually be associated to the requirements in your boards. So if you actually have a requirement, instead of wondering how your test team is actually going to be able to test it, they would link their test cases directly to the requirement for the developer. So in my backlog, I know exactly how they're going to test it. And if you know that ahead of time, you're more likely to develop it to test all the tests that are actually attached to it. If you don't know how they're going to test it, then you're going to code to an assumption that might not match the assumption of the developer who's actually going to be testing it. So I love this integration between the two of them because I know ahead of time as a developer what the manual tests look like and how they're going to test it, and I can develop towards that, giving me a more likelihood of making it through the QA testing that's going to happen on the other side. For the interest of time, I'm not going to show you test plans, but I have a really good video on Channel 9 of where I actually walk you through our test plan feature, so you can actually find that. And then the other one is artifacts. This is a pretty boring demo. It's a badass product, but it's just a list of names of packages that I have in their store. Now, what I've done with the artifacts that I think is really interesting is I've sort of used it as a dev environment. When I was working on that PowerShell module that runs on Mac, Windows, and Linux, it always ran really well on Windows, and every once in a while it would crash on Linux or Mac. You know why? Because I didn't care about casing. I'm not a Linux person. To me, the letter's the same if it's lowercase or uppercase, but to Linux, it's not the same. And what would happen is people would try to install it on Mac or Linux, and it wouldn't work. So what I started doing is instead of publishing it right to the PowerShell gallery, as I would first publish it to our artifact store. And then I would use inside of my deployment pipeline, I would download it onto a Mac, onto a Windows machine, and onto a Linux machine, run all my unit tests again, run all my integration tests again, knowing that if it passes there, when I finally publish it to the PowerShell gallery as my prod environment, everything's going to work as expected. So not only can you use it to curate your own list of packages to make sure that they're safe and that they don't go off and get things that are vulnerable, you can also use it as almost like a temporary or a dev environment to where you want to publish and restore from to make sure that your code works the way it's supposed to when it makes it out into production. Talking fast because I only have 2 minutes, so there will not be a demo of that either. Again, it's literally just a screen of package names. And then finally, you saw these people earlier today. One of them is actually here. That's Damian Brady. He actually used to work at Octopus Deploy. So if you have any Octopus questions, that's the guy you want to ask. If you have any AI and ML questions, that's the guy you want to ask. If you want to know the best developer I've ever met, that's Abel Wang. Open source, Linux, Kubernetes, Jessica Dean, SRE, Windows, DevOps, that's Steve Moraski. So when you use this hashtag right here, we're all going to come running. And a matter of fact, a lot of people inside of Microsoft also are monitoring that hashtag so that they can help you as well. And then finally, again, if you wanted to take a picture of this, this is how you get a hold of me on Twitter. I am Donovan Brown. And that's a lot of different shows that we have. Matter of fact, that one is by that guy over there, Damian Brady. And it's a really different show than the rest because it has like problem and a solution, whereas DevOps Interviews is just me sitting around shooting the crap with somebody who loves DevOps just as much as I do. And it's more like a podcast than anything else. And you're more than welcome to get that as well. I'm going to step outside because I'm out of time, and I'll be more than happy to answer any questions that you have outside. I think I'm the last speaker, so no one should be coming in here after me, but just to make sure that the room is free and being cleaned up. So thank you again for having me here at NDC. Hopefully this was helpful. Thanks. Yep, right on time.